Hello and welcome to today's mathematics class. For this class, we're talking about the concept of Venn diagram. So Venn diagram is from the topic called set. So I've discussed about the introduction to set in our previous class, which I'll be dropping the link in the description of this video. So I have two videos for the introduction to set. So I'll drop the two videos in the description of this video. So try to watch the two videos before you dive into the concept of Venn diagram. All right, so let's discuss Venn diagram. By definition, Venn diagram is simply the diagrammatic expression of solving problem involving set. So the diagrammatic expression of solving problem involving set is called the Venn diagram. Venn diagram is discovered by a logistics called John Venn in the year 1834 to 1883, right? So was discovered by a British scientist called John Venn in the year 1834 to 1883. When it comes to study of Venn diagram, there are two types of Venn diagram. We have the Venn diagram for two sets and Venn diagram for three sets. So when it comes to Venn diagram, there are about two key terms there. Venn diagram for two sets, and we have the second one called the Venn diagram for three sets. So when it comes to Venn diagram, there are two key terms there: Venn diagram for two sets and Venn diagram for three sets. Venn diagram for two sets. Let's start the Venn diagram for two sets. All right, when it comes to the Venn diagram for two sets, note the following. Note that the modern Venn diagram for two sets is given below. The modern Venn diagram for two sets is given below. Please draw the diagram. Draw this diagram. The modern Venn diagram for two sets is given below. Please draw this, please. Let's call this one here. I'll call this one here. Call this one M. Call this one N. So I'm saying that the modern Venn diagram for two sets is given below. So it will become diagram. Let's say you're having two sets, set M and N. The diagram becomes something of this nature, as you can see. So it's also note that there are about four spaces for Venn diagram for two sets. What are the spaces I'm talking about? This is a space here, 1, 2, 3, and this outer part is a space. So note that there are about four spaces when it comes to Venn diagram for for two sets. Now, aside that, let me just try to explain the concept behind these spaces. So let's call this space here. Let's call it space A, space B, C, and space D. This outer part is a space, right? So if I shade this part, observe. If I shade this part, shade this one here. So the one I'm left with, the outer part I'm left with is what? Is D. So let's define these spaces one after the other. What's A? What's B? What's C? What's D? So we said when it comes to Venn diagram for two sets, there are about four spaces. We have space A, space B, C, and D. Let's find these spaces one after the other. So note that A is equal to n of M. That is, A is what? Number of elements in M. So all the elements, look, observe that A is everything here, right? So all the elements in M are A. So A is equal to what? All the elements in M. Sorry. All right, that's for A. For B, look up please. For B becomes the elements, these elements B occur in M and N. That becomes what? An intersection. So B is defined as what? N what? M intersection what? N. So this is M intersection N. This B is common in what? In M and N. So it becomes what? An intersection. We said an intersection is simply when two sets are having an element common between them. So the elements that is common between M and N is what? B. So B becomes N of what? M intersection N. That becomes the definition for B. For C, let's define C. What's C? C is what? N of what? N of N. That is, all the elements in C are what? Containing N, Abi. So N represents what? Every element in C. So that becomes C is what? N of N. And what's D? D is called N of M union N prime. Awesome. Awesome. So it becomes the expression for D. So D becomes N of M union N prime. So there are 4 spaces. We said space A, space B, and C and D. And I've defined the space for you that A is what? A is simply all the elements in M. B is the elements that exist in M and N. That becomes an intersection. C is element in what? In N alone. Why D is what? The combination of M and N. And subtract from what? Universal set. This prime means take away from what? Universal. So that becomes the expression here. All right. With this idea now, let's now take a problem and let's solve together, and let's see how we can apply this concept of Venn diagram for 2 sets, and let's see what we can do. Example 1. In a recent survey of 40 students, everything. All right. In a recent survey of 40,000 students in a school, 1,000 students were listed as smokers. Awesome. 1,000 students were listed as smokers and 1,500 as gum chewer, or perhaps as chewers of gums. I said in a recent survey of 4,000 students, please, 4,000 students in a school, 1,000 students were listed as smokers and 1,500 or perhaps 1,500 as gum chewer, comma, 750 were listed as both smokers and gum chewers. 750 were listed as both smokers and gum chewers. Find out how many students neither smoke nor chewing gum. I said 750 were listed as both smokers and gum chewers. Find out how many students neither smoke nor chew gum. So when it comes to the concept of neither nor, the major idea is basically on this. Look up, please, on this man, the last part. So when neither nor, I'm talking about what? The one outside the what? The set, which is D. Please take note of that, very important. Let's have this question, please. Solution. My very first task when it comes to solving this problem, what do you do first? You define parameters. In that case, this set now. How do you know if a set is 2 sets or 3 sets? I'm having 2 key words there: smokers and what? And gum chewers. That becomes what? A 2 set problem. For a 2 set problem, I'm given that in a recent survey of 40,000 students, that becomes what? The universal set, Abi. So the universal set U is what? 40,000 students. That is total number of students is 4,000 per se. That's my universal set. 1,000 students were listed as what? Smokers. So let you define. Don't just come here and say N of S smokers. No, you define it. Let them know that you are saying X is what? Smokers. So let X represent smokers, right? So I'll be having what? N of X. How many are they, please? 1,000 students are what? Are smokers, as you can see. Next up, 1,500 as gum chewers. So let C represent gum what's it called? Chewers, right? So that becomes N of what? N of C as what? 1,500. So 750 listed as what? As both gum smokers and what? Gum chewers. What that become? That becomes N of what? Listen, I'm given that smokers. I'm given that 750 were listed as what? both smokers and gum chewer. So that becomes an intersection. An intersection that common between them. That becomes smokers intersection what? Gum chewers, right? Has been equal to what there? 750. Has been equal to what? 750. I have this one here. So what the question says, so find what's it called? Find out how many students neither smoke nor chew gum. So let that one, let the student that what's it called? They neither smoke nor chew gum be what? Be X. So that becomes what I have in this case here now. So at this point now, so in that case, look up. In that case now, okay. Excellent. So all right, at this point now, what's next? I've defined these parameters. What do we do next? Let's draw the diagram for this. So for this diagram, I will draw out my, listen, I'll show you how to draw the diagram. For this diagram now, when it comes to drawing diagram, the idea is in two cases. You have your modern Venn diagram, as in this case, and you have what we call the real diagram. The modern Venn diagram, in your exam, you're not expected to draw modern Venn diagram in your note, in your answer sheet. You are expected to draw the what? The real diagram. So your modern Venn diagram will be somewhere else, maybe in your rough sheet, right? Let me show you the modern Venn diagram. So for this one now, for two sets, I have something of what? Of this nature, right? A set here, the other one here, right? So this one is what? My set, what? Sorry, for what? Smokers, Abi? For S, smokers. This for what? Gum chewers. C. Now please, what is here? Here is what? N of X, Abi? Yes. N of X is what? 1000. It becomes 1000. Next up, this is what? Intersection. What smokers and chewers have in common is what? What? 750. So I have 750. What's N of C? N of C is what? 1500. Observe that I'm left with what? The last one here, which is what we're looking for. That's the condition, that's the case now. That becomes what there. We shall call it what? Call it X. Call it X. So I have this one. So it becomes what? My modern Venn diagram. This one, I don't draw this one in exam. Oh. Draw this one in your rough sheet. Now, what's not the real diagram? Here's the real diagram, please. All right, at this point here, I said you derive your real diagram from what? Your modern Venn diagram, as I've shown you now. I said you don't need to draw a modern Venn diagram in exam. What your lecturer need is what? Your real diagram. Let's not draw a real diagram. The difference between modern diagram and real diagram is slightly small, right? What's different? The idea is that I will draw this one again. I will draw this. I have to set there for smokers and what? For gum chewers. Smokers and what? Gum chewers, right? So when it comes to drawing out your real diagram, the only part that does not change is what? Is your middle part. So this middle part remains what? 750. Remains 750. Now, how do you get this part? Subtract 1000, please, from 750. What do I have there? 250. I have 250 here. To get this part here, subtract 15 from 750. What do I have there? 750. So here becomes my X that I'm looking for. X. All right, at this point now, we said when it comes to two Venn diagram for two set problem, there are about 4 spaces there, Abi. So the idea is that recall that N of U, universal set, is equal to the addition of what? All the sets here. So I have what? N of X here. This one is N of X plus what? This one is what? N of X intersection what? Intersection C. This one. This space is what? Is called what? Plus what? N of what? N of C. Next up, plus what? N of what? All I call X. X is called N of what? N of X union C prime. I gave you the definition for this previously now. So at this point now, let's substitute in value and let's get our answer. All right. So from here, if I put in my value from here, what do I get? What's N of U, please? N of U is what there? N of U is 4000. That's 4000. So I'll have n of u, that's 4,000 as being equal to n of x is 250. So I have 250 plus what's n of, that's 750, plus what's n of c, 750, plus what there, x. So the ideas are add this one together. What do I get, please? 4,000 is equal to 250 plus 750 plus 750. That's what there, 1,750, right? Plus x. I want to get x. What do? Take this man here, Abi. 4,000 minus 1,750 being equal to what? X. Give me value, please. 2,000, what there? 2,250 is equal to what? X. So therefore, S is equal to what? 2,250. What does it mean? It means that the number of students that neither smoke nor what? Chew gum is what there? Is 2,250. So that's how to solve this problem using the idea of Venn diagram for two sets. In our next class, we'll discuss about solving problems under Venn diagram involving what there? Involving three